you one more example. Here we are having the sine function coming inside. So we are having the two parts again. Non-homogeneous equation, we take homogeneous part. That's phi d equal to 0. We have y double dash plus 4y equal to 0. Substitute here. We write characteristic equation, that's m square plus 4 equal to 0. And we get here the roots of this one is m equal to plus minus 2i. Alpha is 0, beta is 1. We get it here yc is equal to c1 cosine 2x plus c2 sine 2x. So this is part 1 and this is my yc. Now I can write here my yp. To write yp, I have given here f of x. My f of x is equal to sine x plus e to power x. Now I write my yp standard form is equal to a sine x plus b cosine x plus c e to power x. Now check it. I need to modify this one or not. I can see here there is no repeating roots with this yc and yp because this is cosine 2x. If it was cosine 2x or sine 2x, then we have to modify this one. But here, because there is no sine x, so there is no repetition, so don't need to modify this one. We substitute this equation here in our differential equation. We need y double dash. We find y double dash for this one. We given yp, we find y dash. Y dash is equal to, derivative of this one is a cosine x plus minus b sine, derivative of cosine is minus sine, plus c e to power x. We find y double dash. Y double dash will be minus a sine x minus b cosine x plus c e to power x. I substitute my differential equation. My differential equation is y double dash plus 4y plus sine x plus e to power x. Now substituting here y double dash is minus a sine x minus b cosine x plus c e to power x plus 4y, multiply here by 4, plus 4a sine x plus 4b cosine x plus 4c e to power x is equal to, our right hand side is sine x plus e to power x. The coefficient here is 1, and I put here 0 multiplied by cosine x because I am having cosine x on the left hand side. Now we compare the coefficients. I compare the coefficient of sine x. Comparing the coefficient of sine x, we have here minus a, then here is plus 4a, and then this is equal to 1. Coefficient of sine x is 1. Then I have here cosine x. Cosine x is minus b. Then I have here plus 4b, and the right hand side, the coefficient of cosine x is 0. Then we take e to power x, comparing the coefficient of both the sides, we get here c. Then we have here plus 4c, and then the coefficient of c is equal to 1, so it's equal to 1. Here we get here 3a is equal to 1, and a is equal to 1 over 3. So next we see it here. We get here 3b is equal to 0. So my b is equal to 0. I get here this is 5c is equal to 1, and my c is equal to 1 over 5. Now I substitute the value of a, b and c here in my yp. So my yp comes to be equal to, yp is equal to, a is 1 by 3 sine x, b is 0, so we don't get any contribution from this term, this becomes 0, c is 1 by 5, plus we get here 1 over 5, we're having here e to power x. Now to write my general solution as I mentioned before, that's the addition of the yc and yp, yc and yp. I have yc, this is my yc, this is my yc, c1 cosine 2x, c1 cosine 2x plus c2 sine 2x. Then my yp is plus 1 by 3, 1 over 3 sine x plus 1 over 5 e to power x. So we are having the contribution of this term yp because of the equation is non-homogeneous. So these are the steps for solving the problem. Again, revising it, repeating it. We have two parts. One part is to find the solution yc, the homogeneous part. Second part is to find the solution for the f of x, and that's yp. So the general solution of this one, as I told you, is equal to y equal to yc plus yp. We found yc. For yp, we substitute this one in our differential equation. We need y double dash. We find y dash, y double dash, substitute in our differential equation. The value of y double dash and 4y is equal to sine x plus e to x. We're getting here cosine x. So we put here 0 type cosine x. We compare the coefficient for sine x, for cosine x, and e to power x. We get the value of a, b, and c, solving this one. Then substitute in our yp here the value of a, b, and c. A is 1 by 3, b is 0, c is 1 by 5, you get yp. Then I write my general solution. My general solution is yc plus yp, the linear combination of this one, and that's my solution of my problem, which was non-homogeneous, and we get sine x and e to power x. I have the example, same example as before, but here we're having sine 2x. So as a solution, as we have mentioned, that we have two parts. The first part is we find yc. Yc is the solution of the homogeneous part of the differential equation. I will substitute y equal to mx. I get the characteristic equation m square plus 4 equal to 0. And we get here the roots are m plus minus 2i. And we get yc is equal to c1 cosine 2x plus c2 sine 2x. So this is my solution in the case we are having here. I will just write here, instead of this, I just want to write it again. We're having sine 2x and plus c2, and you can write any way you like, there is no problem. I'm going according to my notes. So this is my yc. The second part is I want to write my yp. My yp depends upon f of x. My f of x is sine 2x plus e to power x. Now I write my yp. My yp is equal to, this coefficient is a constant, so we get here a sine 2x plus b cosine 2x plus c e to power x. Now we can see it here that in this case we can find that they are repeating. We're having here yc. We compare yc and yp. This is c1, sine 2x a, sine 2x is a constant, so it will be not a new value we get. They are not linearly independent, so multiply here by x. When root is repeated, multiply by x. Again here, we are not having this repeating, so we multiply by x. So we modify our yp. Now modify our yp, so we substitute in our differential equation. We find y dash, we find y double dash, and substitute in the differential equation. I just write the last result when we compare the coefficients. In this case, then we get the value. I'm just skipping the details of this one. You can do yourself, or you can take it from my notes. As I mentioned that you can get my notes in the description, and the solution of this example and more examples are given in the notes. You can take it from there. Again, as before, don't forget to click the bell so that we get the notification. We are having the continuous course for this one, and you can get the next lecture so that you can just continue with my differential equation course. So here we get the value of a. After solving it, we get the value of a equal to 0, value of b is equal to minus 1 by 4, and the value of c is equal to 1 by 5. So I get the value of b and c. I substitute in my differential equation yp here in this one, the value of a, b, and c. I get here yp. Yp is equal to a is 0, b is 1 by 4 minus 1 by 4. We're having x cosine 2x, and here plus 1 by 5 e to power x. So actually this is the difference coming in the last example. In last example, the root was not repeated. We have not modified our yp because that was sine x, so you remember it. But here 2x, so we get here c1 sine 2x, c2 cosine 2x, and here a sine 2x, b sine 2x, and here we need to modify it. But the other steps are same. So we can write our general solution. Our general solution in this case will be our yc plus yp. Y is equal to yc plus yp. We have calculated it. So we get here y is equal to yc is equal to c1 sine 2x, and plus C2 cosine 2x, and then we having here yp, or yp is minus 1 by 4 x cosine 2x plus 1 by 5 get 8 pi x. Now you can see here, especially when you look on these two values which are containing cosine 2x here and here, because of this x, this is distinct from the first one, and that's why we say we modify our yp and we can write our solution. So this is the example I have given to you, as we are limited in case we are using the videos lectures. So I will ask you to solve many problems. So you can't learn it without solving a problem. For problems you can get from my notes also, from the books also, you can get plenty of problems. Make practice. These are the fundamentals which you need in your engineering or in mathematics or physics. In the science courses, solving your projects. In your projects you will be getting the differential equation and you need to get the solution of that one. If you are master in solving the differential equation, then your research will be very easy for you. And also you are having the senior courses in your MSc or MPhil. During PhD you need some techniques for solving the problems. So this helps you a lot. Thank you very much. Inshallah, till next video.